Hello, everyone. How are you all doing today? Welcome to the panel discussion on the path ahead for Terabit Hyperscale Cloud Computing Networks with Artificial Intelligence and Machine Learning and the Edge, sponsored by Keysight Technologies. On behalf of Keysight Technologies, I would like to thank you all for joining. We are immensely pleased to have you here for today's panel discussion. My name is Girish Baliga from Keysight Marketing, and I'm the host and moderator for today's panel discussion, and also will develop as a panel member. Today, we'll be spending the next 45 to 60 minutes or so deep diving into the path ahead for Terabit Hyperscale Cloud Computing Networks with AI, ML, and the Edge. Let me take this opportunity to introduce to you the esteemed panel for today. Joining me on the panel discussion today are Mr. Pradeep Junjunwala. Mr. Pradeep is the Vice President and Head of Cloud Engineering at Reliance Jio. Also on the panel, we have Mr. Vikas Chip, who is the Senior Data Scientist at Infineon Technologies India Private Limited. And we also have Mr. Sudipta Saha, Associate Managing Director at Accenture. We welcome you all. And we would also like to thank you for taking time out from your busy schedule and participate in this panel discussion. As all of us know, in this industry collaborated panel discussion with the high-tech industry ecosystem senior leaders, we will deep dive, deliberate, and discuss threadbare on how cloud is evangelizing the data center industry and opening up new market horizons and its path forward. So, as we know, our whole world is connected, and the pace of communication innovation is accelerating as the end users demand faster, more responsive, and more reliable communications. Communication links are both wired and also wireless, and these days, depending on the end use, it would cover various applications that are connected through to the last mile through Ethernet, and where you have a backbone which is predominantly optical fiber. Then we have cellular wireless and other wireless data communications like Wi-Fi, etc. What we specifically see, specifically talking from the testing standpoint, right? The test increasingly needs to span several of these domains, starting from various capabilities which need to be handled, whether it's the hyperscaler or the data center, the server farms, and so on. So at the end of the day, we need to ensure that these are all tested, spick and span, and ensure that the user has the first mover advantage and they get first to market. So moving forward, what we also see that is the demand for faster data is continuing to grow. And cloud-based services, video streaming, Internet of Things, specifically talking about 5G, IoT these days, right? And 5G connectivity and more, they put a lot of strain on the communication network. So network infrastructure, as we speak, right, in the communication industry, especially the data center interconnect or DCIs in short, they should also evolve and transform to support these needs. Today, we see that as we go towards higher bandwidth transfer rates, we also need to ensure that the energy efficiency goals are also met. So, like I mentioned earlier, optical technology is one such facet which ensures that the data points are met. But having said so, this also leads to a lot of new developments happening in the integrated circuit technology or the systems level engineering, or even when you are talking about cellular communications, we see that the world is leapfrogging forward at a very rapid pace. So specifically, when we talk about the semiconductor world and systems engineering, we talk about applications like 400G, 800G, 1 terabit. Now the word in the market is more to talk about 1.2 tera as well as 1.6 terabit and so on. So to take this entire challenge and ensure that this is mitigated, there are hosts of opportunities for everyone to make money, as well also to ensure that these terabytes of information are kind of transmitted over various methodologies, both wireless, and ensure that these demands are met. As all of us know, the data center connections are usually many kilometers apart. And there are a host of signaling standards which are being used, moving from the NRZ, which is the non-return to zero. And these days, everything is happening on PAM technology, or the pulse amplitude modulation, and specifically talking about PAM4. Today, we see that many distributed data centers in a campus or a metropolitan area, or probably even in a wide area network and so on, right, need to ensure that they are significantly connected with the increased interconnection capacity. So that means to say that the demand for faster and more efficient data center infrastructure transport is required. So we see that when we talk about distributed data centers, they need to ensure that they share data, they balance the workloads, and they provide backups and scale capacity when needed. So this is a challenge as well as an opportunity to ensure that these massive data centers are connected with kind of an exponential growth in speeds, and that also opens up a wide horizon for various cloud services, as well as today we talk about the edge, and then encompass that with the artificial intelligence and machine learning, right? That's going to spawn a host of a new set of applications which were never heard before. So with that kind of brief background, right, I would like to now open up with this panel discussion and set the stage so that we can now deep dive into what we want to discuss in the context of today's panel discussion. Participants and viewers, this topic is going to be highly technical, and discussion will be intense. So before we shift gears and start with the panel questions, dear participants, couple of housekeeping questions. During the course of the panel discussion, you will get a poll. Please share your candid feedback on the survey form. There are two ways it would pop up. One is it would be a pop-up on your console window, and also we will be sharing the details of the survey on the chat box, a hyperlink. Please feel free to dial in your details. And also, you can share your questions as well on the chat box during the panel discussion. Obviously, when there are a lot of technical questions which have been discussed, you will definitely have a lot of questions that want to get answered. So we'll be more than happy to answer your question. Please share your questions on the chat box. And it's not that we may have answers for all the questions, but we promise you that if there are any questions which are unanswered, we will get back to you offline without fail. So without much ado and shifting gears, so let us start. So first of all, to begin with, I would like to ask this first question to Mr. Vikas from Infineon. So Mr. Vikas, from your background, right, can you please enumerate how artificial intelligence and machine learning is helping facilitate the drive next generation cloud and big data? Over to you, Vikas.
Okay, thanks, Girish, for your good introduction. So basically, whenever you talk about machine learning, big data, and cloud technology, so in Infineon we are working in a three layers. So let me explain you a little bit in brief what I meant here. So whenever we talk about these technologies like big data, cloud, or AI, ML, they are interlinked to each other. When I say interlinked, it means that first you start with the problem statement, you have AI. Then for solving the AI, you need big data. And now for scalability, you need cloud infrastructure. So this is how you interlinked. And after that, once these things chain or this complete interlinked chain get bigger and bigger, then what you need is you need again AI to optimize the stuff. Yeah, so that's how this chain get closed. And in Infineon we have, in first layer we are doing various kind of applications in every blocks. So we have the various use cases in NLP also, like information retrieval, search engines, and all. Then we have in operations, we have manufacturing use cases which related to computer visions, and I would say object detection, lidar object detection, autonomous vehicles, and all. And the last one, if I talk about this in big data stuff, we are now moving in the direction of data lake and data meshes, and which is one of the hot concept in the area of big data. And similarly, we are in the cloud side, we are using container as a service. So this is our first layer. Talking about second layer, we are providing all the three components, which is AI, big data, and cloud, as a one package. We called as a, you can say, platforms as a service, where we are providing end-to-end service to our customers. And when I say customers, it's mostly our in-house customers, and where we can provide ML platform as a service, and also we are providing this kind of data mesh as a platform. And the last one, and the last layer is, which is also very crucial, is we're also trying to improve, I would say, and also do some research papers, writing some research papers, and giving back to the community, open source community, I would say. So this is how we are working in the three layers. Yeah.
Yeah, thank you, because that was a pretty good first perspective which you mentioned, specifically talking about how you provide facilitation for next generation technologies like the cloud and big data. So moving forward, because just to add as a rejoinder to your question, to the answer, right? So from
Mhm.
your perspective, how do you visualize next generation silicon geometries which are going to cope up with specifically with the to cope up with and inculcating blazing speed which is needed for big data computing, right? And
Mhm.
this goes hand in hand with very high speed wireless technologies like 5G. So we'd like to get your perspective, Vikas, on this.
Okay. So see what you just said now, right? So there's a war going on. No, I will not say war, but there's a perspective is going on in the market: cloud AI and edge AI, right? And if you ask me, right, the industries or market is split into these two. There are people, or there are industries who are investing in the cloud AI, in the same direction that you just mentioned now, that we should have a high hyperscalers, good data centers with a high bandwidth and all, so that we can reduce the inference, or and also reduce the latency between the network and the model, let's say. And second area is we have edge AI, where we are focusing and trying to invest in the hardware, where we are saying that, okay, let's deploy our models and everything on edge itself. We don't need a cloud, because cloud comes with the data privacy and all. But let's not focus on the edge AI for today, but today the focus is cloud AI. If you ask me, the future, if I see, is going in this direction. The reason is, if you ask me, right, what is AI on edge apart from data privacy concerns, I would say anything which you can give the response less than 10 milliseconds, right? That's AI on edge, yeah, for me. And for example, now we have, I heard somewhere from Cisco Silicon One, they are coming with the chips which less form vectors and all, and has a speed of around in terabytes. Yeah. Similarly, Juniper Networks is also coming up with the same kind of chips formation, and now they are saying that it's better than the Cisco one. So you see that market is going in this direction, where they are investing a lot of in the hyperscalers and data centers to reduce, I would say, inference speed with the models. And I would say that in future lies here, because in the end, what we want is, when we have everything in cloud, you giving a better solution to the customer and the cheaper cost. So that's how the market will grow. But no comments on the future perspective, but this is my current scenario. Yeah.
Think I sorry, I was on mute. So thank you, Vikas, for this very insightful perspective. You're right. At the end of the day, we are here to do business, right?
Yeah.
And we also need to ensure that we need to kind of differentiate on technology, and specifically talking from test and measurement perspective, coming from Keysight Technologies, right? We
Yeah.
always say in marketing jargon that we are on the uh, edge of the next generation technology curve,
Yes.
right?
Yeah.
Because by doing that, we see that, okay, if it is a PCI Express Gen 5 or Gen 6, or
Yeah.
you're talking about the next generation memory technologies, or you're talking
Yes.
about things like transmission test or receivers test and so on, right? We ensure that we have the bleeding edge of test technology, so that when silicon vendors or system designers, or even we are talking about folks like NEMs and operators and so on, right? So they have a rugged test methodology even before these things are put in perspective. So the kind of background which we operate on. And I totally agree with you. These things matter a lot, because that is what is going to kind of separate the wheat from the chaff, so to speak.
Yeah, yeah.
So having said so, right, so let me ask Mr. Pradeep from Reliance Jio now on his expert perspective on how he can help us understand on how cloud computing can dovetail with the 5G Internet of Things, or 5G IoT in short. Over to you, Pradeep.
See, 5G and cloud are made for each other. Okay? And this is going to change the way we look at every application, what is happening today. Edge is something which is not even future, Edge is right now there. We at Geo has implemented a couple of Edge already, Edge computing already. And when you look at Edge, let's define the Edge properly, because that's where the people see a lot of challenge. There's an MSC Edge, which is a 5G Edge. There's an Enterprise Edge, which will come up big way. If I look at India itself, India will have 25,000 edge computing or fog computing, whatever name you want to call up it. And the edge will be edge with IoT, small IoT device serving a manufacturing unit, or a single server unit for doing some artificial intelligence at the customer location. Or edge will be at enterprise edge, which we are planning to build for all our uh, customers, which is sitting next to the 5G interface. And you look at the use cases, correct? You look at metaverse coming in. And metaverse is going to be there in the next 3 years. They're going to use metaverse as our kids use Roblox, correct? Which is one of the starting factor of metaverse. People will require that quantum of data. With 5G coming up, you'll have HD video everywhere. Surveillance video suddenly from standard definition will move to high definition. And the amount of data which they will pump in to a cloud without the edge, it will be impossible for us to get everything on the central database. So you will have edge computing running those high-end algorithms for just making sure that we do the detection at the edge, but all the main computation, all the machine learning happens at the central computing. So if you look at the whole 5G world and cloud computing, this is going to give a huge boost to the way the cloud is going through. And you will see data centers literally at every home. Might be in the form of a Raspberry Pi or whatever big processing power which you're getting in, which will do local computing which is required, and everything going to the central computing for all the great machine learning, all the great storage what is required. So that's the word. That's the word which is going to have. Connected vehicles can't run with single cloud computing, and connected vehicles will happen with 5G. So when you have connected vehicle, autonomous vehicle, the amount of data per hour they pump in, we require edge, we require 5G, and we require the central computing. All of that has to come in. So the whole ubiquitous computing is going to happen with 5G, edge, and cloud. So 5G is something which is going to really bring in the cloud to the next generation. 5G is going to bring in a lot more application, a lot more customer experience to the next generation. All that is going to happen. So what we have seen of cloud right now is the tip of iceberg. With 5G and all the new technologies, we see cloud really flourishing. People will have new edge applications. People will have new edge of customer experience. People will have new age technologies. The way we are talking today on Teams or Zoom call is going to change, because we'll have those immersive experience where we'll feel sitting next to each other. That's what 5G edge and cloud is going to do. So for me, 5G is a technology which is really going to change the way we work today. 5G is a technology which is going to change the way we live in future. That's the importance of 5G, and all that is backed by edge and the powerful cloud computing what we're building. So that's my perspective on 5G and cloud.
Yeah, thank you, Pradeep. I mean, that's very well said, because like any disruptive technology, right? So what's going to happen is we are going to see a host of new applications and the kind of technology sub applications, right? Where these would be applications which have never been heard of. And with the COVID disruption which happened, right? So the virtualization and so on, this is going to stay. And having said so, edge is going to play a very, very important role there, especially when you are talking about the last mile, and also to ensure that things are viewed in a different way, especially when you are looking at work from everywhere and so on, right? That's going to stay. It's not that it's going to just, okay, COVID is gone and we are back to office, right? So these two will be kind of complementing each other and ensure that things are moving in the right direction. And having said so, like you rightly mentioned, right? So 5G with Edge is going to ensure that there would be a lot of new applications which we will see in the market, and that's going to be very exciting things to come in the near future. So with that, I would like to ask this next question to Mr. Sudipta from Accenture. Sudipta, with the cloud getting ubiquitous and security being a vulnerability, right? So how are cloud innovations ensuring that the security gaps are mitigated to avoid potential pitfalls? Obviously, the technology is going to kind of leapfrog, but with that comes on the platter a lot of vulnerabilities, especially when we are talking about the cloud. We would like to get your expert perspective on that, Sudipta. Over to you.
I think it's a great question and very timely as well. I think the security is always the foremost importance, but if you see cloud computing coming into picture, it really puts the systems on anvil in terms of resilience test, right? Now, when I have to talk about the threats, probably I will classify them into 5 broad areas, and what I will also like to tell you that what are the causes and effect of the threat and how we can mitigate that, right? So I think the 5 areas which I want to highlight is data theft is one. The account takeover is another very important one, and the denial of service, which is increasingly becoming a menace. This is the third one. The insecure APIs, that's another very important thing with a lot of the APIs being exposed to the partner systems, and the configuration errors that typically happen in the cloud infrastructure. Now, first, let me talk about the data theft, right? Now, data theft is a very pertinent topic. It has been discussed a lot. I would not deny that there is a role of shadow IT in managing the workloads and inaccurate setup. So, what is this shadow IT? See, many a time what happens is that there is a CSP, but at the same time there is a client organization which tries to take certain amount of control in terms of the cloud configuration. They may or may not be always well trained, and that causes a lot of issue, right? This causes the leakage of company sensitive information, reduced infrastructure visibility, inability to locate the data storage, all that thing, right? So how we mitigate? There are quite a few things, but I would highlight on three things: multi-point encryption, data encoding, and most importantly, a very robust security architecture. Okay, that's the first and foremost important thing. You have to prevent this. Account takeover, which I discussed, is today, as you know, that a lot of cyber criminals are there around, and they are trying to get access to your organization domain. How it impacts? Of course, it is, I think, basically they take the data and privilege of the systems of the compromised account, and through that they try to proliferate into other accounts, right? And it becomes really big at some time, which you can't control. Definitely, there are a lot of mitigation steps, but I would definitely talk about the identity management, authentication, and access management, the 3 tiers, and multi-point encryption is another very important thing, which I talked about before, right? Now, denial of service, which is another very important thing. Now, this one is, it is basically a malpractice by a lot of entities which tries to, multiple system flood the bandwidth or resources of the targeted system in such a way that, it basically you can't get the required service, right? It impacts by attacking target resources or services to render them unavailable, okay, by causing a huge traffic, right, and which is unreal, right? Now, how we tackle that? There is quite a few advancements happen. See, there is a certain we have been working on certain the innovations in terms of how we detect the attack using correlations with the distance of the attackers and the workload patterns. Okay, so this is some algorithm which can help you to detect that whether it's a real traffic or unreal traffic, right? So moving on, the next one, the insecure APIs, right? The data, if you study the data, you will see that two-thirds of the organization expose APIs to public or business partners, right? Now, this definitely poses a lot of challenges because obviously you can't deny doing that because then the external developers cannot work on your system because there are a lot of third party you have to integrate and so on, right? And this causes a lot of stealth of sensitive and private data, right? So what do you do, right, to prevent this? The most important thing is that you have to maintain the API hygiene. Now, this is something we forget many times when we create an on-premise system. But when you are exposing this to cloud, you need to be extremely or ultra sensitive about this aspects. In Accenture, we are very, 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 very particular about these things because ultimately our client will only trust us when we ensure that their data is completely secure and there is no insecure APIs. And of course, all the authentication, access control, encryption, activity monitoring. Another very important aspect is that API keys should not be reused. That is a very, very important thing we should always maintain. Last but not the least, that there is some configuration errors which can be to the picture. Now, this happens because of inaccurate setup of the hardware and software details. Now, the way it impacts the system, first of all, it creates some suboptimal performance. Then very, very high subscription fees. I think this is a very, very common problem with many customers which are first time using cloud, that they ask a system, but that when they look at the bill, they fall from the chair, and that's because of not doing the configuration properly. So how will you tackle this? Now, definitely we have to use the right instances, put data in the right place, and we don't should not do, most very important, should not over to the microservices. Many times we try to, in order to go to a microservice based architecture, we try to put everything as microservice. Not needed, not needed. You have to do it very judiciously, and we have to use the load balancer to monitor performance and then automate whatever is possible. So these are the few things I thought I would like to highlight.
Thank you, Sudipta. That's very well said. In fact, specifically ensuring the network is uber secure, right, is the need of the hour, and that also ensures that there's not a lot to do on that front as well. And like we all know, right, security is never static, right? There are new threats which are ever present, and many a times it so happens that the misconfigurations can also compromise the network in an instant. And at the end of the day, it needs to, especially talking from the instrumentation perspective, right? Cyber security is the need of the hour that needs to be taken care of. So that's where the simulation also comes into picture, where by safely simulating the entire kill chain, right? So the user can definitively measure their risk mitigation, and also ensure that if there are any gaps, they can course correct and ensure that they provide step-by-step remediations. So totally agree. I mean, security is going to be the next big thing which needs to be taken care as the technology advances. So just taking I mean, as a gatekeeper, right, I would like to ask the participants on you can dial in your questions in the chat box and also fill up the details of the poll, like I mentioned earlier, right, which will be available as a pop-up and also on the chat box as a hyperlink. Please feel free to enter the details on the survey form. So with that, I would like to direct the next question again to Mr. Pradeep, specifically again continuing more on the security side of things, right? Pradeep, can you please throw light on how we can validate the security resilience in the cloud environment, right? Especially keeping in mind the data center needs. Over to you, Pradeep.
Yeah, so if I look at security, correct, I break up security into two pieces. One is the data security or security provided by the data center provider. And the best part is every data center provider does the best job to his ability to put that job. So physical security, access to the servers, the whole RBAC, and especially when you go to hyperscalers, people like Azure and everybody else, they do a a step notch above everybody else. And that's where Geo partnered with Microsoft to launch our own Azure, Geo Azure, what we want to happen in Westman. Because the physical security really goes to a different level. But the other side of the security, which is the client side security or when the application side security, the companies who are hosting on cloud, they need to understand this is a joint responsibility. There's a perception in the market that if I host on cloud, everything is secure. And this is what kills the whole security framework itself. Secondly, people need to understand that suddenly when you move to cloud, the security boundary has broken up. Think of it. Up till now, you were in your own data center. So you had your own lagoon, you had your own parameter. Now you added one more layer to it, which is Office 365 to productivity suite. So suddenly your whole device-based security or your whole parameter security is broken up. Now you have a pipe going to your Office 365, and there is data going out, and people are accessing that. So that get broken up. Now you add Azure to it, or you do Geo Azure to it. You have one more layer broken up. Then you add one more third-party SaaS. So suddenly what happens is something which was a closed loop security in the data center where you used to control that from only VMZ my internet is going to go and everything is so secure. Now you have multiple points which are gone up. So suddenly what enterprises are realizing is that from a basic device-based security is not going to serve when I move to the cloud. The idea of device-based security is gone with these days. So you need to move to something called zero trust security, or you need to move something called identity-based security, where you don't trust anybody because you don't have boundaries, correct? So you don't say, okay, this device coming in from this place is going to be secure. What you start doing is distrusting everybody. That's what the basis of zero trust security is. So anybody coming from anywhere or logging to any computer or any application accessing, you don't trust that. So everything is inspected. Everything is make sure that whoever is coming in has to be secure. By default, I don't trust anybody, so every connection coming in has to be secure. That's the way we make the whole system zero trust security. Secondly, what has happened is suddenly understand the hackers or the people who breach the security has become more powerful. If you look at the total sum of the revenue which a ransomware community makes, is higher than some of the small countries' GDP. Look at the amount of money they have. So they have no sophisticated tool. And if you look at the time it takes for a ransomware attack to happen, is actually more than 6 months. So somebody is sitting in your network for 3 to 6 months harnessing your data to understand which are the important computers, which are the important people, which are the important data to harness. And then they go and block it and ask you for money. Because there have been instances where people have gone and bought insurance against ransomware. And the ransomware people went and first hacked the insurance company to understand people who bought the ransomware for protection. And then they go when each by each asking those companies for money. So the attacks have become more sophisticated. So we have to have our defense mechanism which are much more changed. Whether this is cloud or no cloud, things has changed in the new security paradigm. Cloud gives a basic security which makes it easy for people to focus on the right layer of security because all the figures, all the data center security of physically checking in data centers, all the RBACs are implemented. So we have now software tools which can do a lot compared to previous data center, which this cloud enables you. But as a user community, you need to really go ahead and implement those checks and balance. We have things in cloud which are way ahead in security, like confidential computing, where the data is encrypted in the memory when it's getting processed. So we need to actually put all the process, people, and technology to right use for cloud to make it secure. We can't just think that okay, we have moved to cloud, things are by default taken by the service provider. It's a joint responsibility, and we need to make sure that we adhere to that joint responsibility. We understand that security is the biggest lever of innovation today, because if your data get compromised, the biggest thing what it get compromised is your company name. And if you can really have a good secure system, that can be something which is big. And that is where a lot of companies are investing today. And that's why you see security becomes so powerful in this today world. The demand of security professionals is becoming very, very high. With cloud, you have people, process, you have technology which can help you do that. What you need to develop is processes and have the right people to implement those technology. and have the right balance between the need and the security, the business need and security, so that the business don't suffer because of over security, or business don't suffer because of the less security. You need to have the right balance, which is very, very critical. So that's what the cloud enables you. They give you all the tools to implement it, but we need to implement it in the right manner, understanding the business need, understanding what is changed in the new world. And the security has certainly changed completely in the new world. There's no more device-based security. There's no more security which is based on DMZ zones. There's no security which is based on, okay, this is my uh, branch office which will only connect to data center and then it will go to internet. That world is gone. Now every branch office goes and connect to office system directly, get the data. You are opening port. You are you're doing opening internet everywhere. So now what you need to change is from a device-based security to identity-based security. What you need to change to is a complete zero-based trust. So you don't trust anybody. The whole thing is designed for everybody not to be trusted. And that's the way you should go about doing your security. That's what is super important. Uh, Embrace the new technologies, embrace the new tools, embrace the new philosophy of security. That's where you can be safe. And, and again, on the point of repeating myself, security is always a joint responsibility with the cloud provider and the customer. And everybody need to understand that. If you understand that, believe me, we'll have much more secure systems, which will provide our customers with better data security, our internal team with better data security. We have all the tools to do that. We just need to have people and processes to make sure that we implement the same.
Yeah. Thank you, Pradeep. In fact, you highlighted a very, very important concept, right, of zero trust. And the industry has seen a growing trend around this security concept called zero trust, right? So, zero trust, like you mentioned, is not a singular point product, but rather a combination of different solutions which are working in concert with one another, right? So, and the zero trust, like you rightly mentioned, right, can come at various phases depending on where it needs to sit, right? So, and depending on where it needs to really get inculcated, you can kind of work with the various partners. And we see that Keysight as instrumentation company is neck deep into these kind of applications as well. So, moving forward, right, I would like to now point the question to Mr. Vikas. Vikas, specifically coming from Silicon perspective, again, I would like to know what's the play for neural networks and deep learning as well as natural language processing with the next generation silicon for hyperscalers, data centers, and the edge. Over to you, Vikas.
So I would say when you talk about this silicon-based hyperscalers, right? So previously, what happened is that let's take a common example. We have NLP algorithms called BERT, which is launched by Google, right? They are very much memory consumption oriented. So if you have to host it somewhere, you require high computation power, and also when you deploy it in the server, the inference time is very much high. And if you want, let's say, production critical applications where you want inference to be high, then inference time need to be low. Then what you need a place where you can host deploy these kind of solutions so that the inference or let's say the inference time or the application performance time can be improved. Yeah. And I would say for this whatever the hyperscalers we are coming getting in the market now, it will open up the landscape for various AI ML use cases in the industry. And the various examples I can give it to you that previously when we doing this kind of, let's say, uh, wake word detections, right? So we started with this okay Siri or okay Google, hello Alexa, right? Previously we were limited to this, but now what we are doing complete speech recognition through AI, right? How it is possible? This is possible through hyperscalers only, right? And now even in Alexa, if I'm whispering to Alexa, right, so it also give me the response in the same voice whatever I'm doing. So this is how the market is going. Yeah. And not only this, you talk about Tesla, same concept. So how these things are possible? Because we have high computation available through hyperscalers which improve the efficiency. And now the with the, like I mentioned it earlier, the technologies that we are coming up with, a one silicon chip which do all your things like storage, memory, networking, everything together. it will reduce the form factors also. And I agree with Pradeep's one comment that at the end we have some devices which is local, like a Raspberry Pi. I consider that in future, let's say next 5 or 10 years, I'm not sure because I'm not expert in that. Like we have towers, right, everywhere to make our inference faster. We have these kind of data centers located like in the same way, because automatically in future the form factor will be reduced. And yeah, so that's what I feel, that in future the scope of AI, right, what we have, I would say, still limited. We can do a lot of things in AI, and this is through possible through this kind of powerful machines. Yeah.
Yeah, thank you, because in fact, there is a lot of AI and ML and NLP which will get added
Yeah.
as part of data center and hyperscale innovation, which also encompasses the cloud going forward, right? And specifically talking about the NLP, right? That's going to also play a big role. And we have been working with a host of ecosystem players
Yeah.
where they are taking NLP, or the natural language processing, to the next level, right? And because ML and AI have unique capabilities with respect to analyzing unstructured text data, right, and ensuring that that juxtaposed with natural language processing is going
Yeah.
to spawn a lot of killer applications. Thank you for that perspective. Um, Vikas. So moving over, I would like to next point this question to Sudipta again, and specifically talking about software virtualization, and specifically we would like to understand what's the play for software virtualization with respect to distributed cloud, and obviously we take that part of it, but specifically talking about cyber security measures and keeping big data in perspective. Over to you, Sudipta, if you can highlight your thoughts.
Sure. So, as you know that virtualization is a fundamental technology that powers the cloud computing, right? It performs all the functions which a typical hardware would do. So it's basically software emulating the hardware, right? Now, of course, we have different types of virtualization in place. We have server virtualization, storage virtualization, network, all that, and each has its own way of handling things, right? Now, if you see, for example, what is the best way to handle this virtualization? There are certain ways to do it when it comes to private or public cloud. There are, because of the inherent nature of this kind of cloud. So, if, for example, when you're using a private cloud, right? So your aim is to actually maximizing the existing resource. So basically that is the main goal. So it will allow the user to keep physical system to the minimum, getting greater value of the existing hardware because you have to maximize the data. The second aspect which comes into private cloud is that running multiple applications and their operating system on the same hardware, because you are it is a physical hardware which you're maintaining, so you have to see that how the multiple applications run at the same time, and the ways also run on multiple ways also can run on the same hardware. And costs are direct and fixed, because if that doesn't happen, then what happens is your whole budgeting for the cloud will go haywire. In fact, it will nowhere be close to even what you have planned. So basically, that is a very important thing. As opposed to private cloud in case of public cloud, right? So it is outsourced, right? So basically, what happens is you are relying on a service provider, right? The administration and all the supporting services are taken care of by the service provider. Now, so this is where the challenge is slightly different. So first of all, your setup has to be very easy and fast, right? Servers, hardware, software, all this kind of thing you are eliminating from your jurisdiction. So it is service provider who is taking care of that. The second aspect is that there definitely has to be a model which is, of course, pay for the use. Now we have gone ahead far in terms of creating different type of service models, but the ultimate important thing is that how the users can pay only what they use, right? And the flexibility, scalability, those are the very important aspects which drive this. Now, though both the permanent and temporary scaling option must be there, because the business can off and offload the high demand requirements if needed, right? So they can actually do the anything which is not so much of hardware intensive. They can do themselves, but then that ability to actually offload those requirements to a public cloud is important. I just close with telling few best practices for virtualization. For example, both the host OS and virtual machines running at the same time must have enough memory, right? That's very important. Enough disk space is important, right? Both which includes enough for the virtual machines, paging file, and the RAM contents. Then you have to identify where this large memory is available, right? So that mechanism should be available. And then if there's any threading technology, it's better to kind of disable them, because otherwise under heavy computing workload, the performance can suffer. I think there is another very important thing which people say is that, when you're doing this virtualization, you better protect the parent disk, because otherwise it may overwrite of this and they may lose the data. So it's very important. And then if you're securing, you have to secure all the virtual machines just as you would the physical machine. That's very important aspect to mention here. And if you are be certain that you shut down all the virtual machines before you shut down the host server, because that controls the complete data flow into other machines, because that's to host the server. And of course, you have to keep an event log to see that what is happening. In case you have to kind of go back to trace back to the previous configuration, this is what it will help you, right? So these are the few things which are I would say that good practices to follow for the virtualization.
Yeah, thank you, Sudipta. In fact, you hit the nail on its head, right? So we have now hit an interesting point in the data center world where organizations need to proactively work so that they reduce the complexity and optimize their existing infrastructure and ensure that they give the world-class end user experience, right? And how this is done depends on the ingenuity and innovation that happens, so that there is data everywhere, there is big data, but how that is harnessed and also ensuring that the security aspects are also catered to with ensuring that zero trust is part of the entire bundle, right? So that becomes huge challenge as well as an opportunity to kind of look into something new which was never heard of earlier. So with that, right, I think we have another 5 to 10 minutes. So I think we have another round of questions for each of the panel experts here. So I would like to direct this question to Pradeep, especially coming from the wireless world, but there's a lot of play which is going to happen, and that's it's going to be the new buzzword, or rather than telling it's just a buzzword, it's going to be for real, right? Specifically talking about the focus area, which is 5G private networks, right? So how from your expertise you would feel that 5G private networks is going to play a role, especially when you're talking about the cloud as well as hyperscalers and data scalers, and especially when we talk about industry 4.0 and so on, right? I mean, there's some kind of confusion on industry 4.0 and 5G private networks, though these are complementing each other. We would like to get your perspective on how 5G private networks is going to play a very, very important role, especially from next generation data centers. Over to you, Pradeep.
Yeah, so the word which we have to look at is connected. And that's very, very important. So although we are living in a world which seems to be very connected, but the industry 4, if you look at industry 4.0, that's the most important word. In the next 10 years, everything is going to be connected. When you look at a pump to a solar panel to a windmill, everything is going to be connected. And look at the whole area of security coming, putting a challenge to the word connected. So connected, great, but all the attacks happening on the PLC system is a challenge, right? That's where the private 5G and the cloud comes in. how you do connected of all the equipments lying in your plant block, or how you do connected of all the big solar farms or the wind farms what you're going to build, or the mines what you're going to build, correct? Because if it's not connected, we can't harness the data. All the machine learning, all the NLPs what we're talking about is no use of. And the real-time data is most important. A data which is 24 hours delay will be actually a stale data, or even a 4-hour data, delay data will be a stale data. So connected, security, and data are the three words which will drive the 5G and the cloud world, especially the private 5G, because there's no other way to actually connect everything which is running in a mine rather than private 5G or private 4G LT, which those guys will give you. Plus, adding a secure way is private 5G. So you want to have a secure connected experience, you go to private 5G in a very, very seamless manner, and that data can be pumped in a with a huge amount of data which is going to get generated. With private 5G will be getting pumped to my edge cloud, where I'll do the right NLP, and all the models getting trained in the cloud. That's the chain what we're looking at. So from a sensor to edge cloud using a private 5G, where I take the right decision, which is sub-millisecond decisions. Those decisions are taken to save life, to get more productivity, to get the right decision, is what private 5G will do. And the huge amount of data which is required to relearn the model is where the cloud will come in picture. So that's the whole chain which will really change the world, way we look at world. Or look at all the autonomous cars which is going to come up, correct? Or the electric vehicles which are going to come up. Those 5Gs has to be secure. I can't have a regular internet connection going to my edge data center with 5G. Look at the security challenge which it brings in. So I have to have a private 5G which actually just allows that particular car to talk to a particular server at the back end. That's my 5G private 5G connection. So that it is secure in a manner that hackers can't get into it. So I'm securing the whole network that way. So that's where the private 5G is going to come up. All the in the IoT, OT security which we're talking about, Industry 4.0 is going to be delivered through a private 5G. So private 5G is going to change the way the whole manufacturing world, the whole new customer experience is going to come up, because security is going to be challenging, and 5G is going to provide that security for people. 5G is going to provide not only connectivity but the security also to people. That's why this is super important, and that's why this technology is going to be game changer in future. That's a quick 30-second overview on what 5G and cloud and edge computing will do together.
Yeah, that's right, Pradeep. In fact, this is going to have a new play, right? People try to compare the 5G private networks with VPN and so on, but compared to this, right, this is totally going to be a different ball game altogether. Especially when you are looking at automation and next generation smart factories, or you name it, a private 5G is going to play a very, very huge role, right? In taking things forward. So I think we have time for one or two more questions, like I mentioned, right? So I would like to direct this question to Sudipta, and this question is primarily on specifically talking from his expertise, right? So as we see, right, data centers have now been now moving closer towards the edge, and the data centers of tomorrow will look very, very significantly different than what we are using today, right? And specifically when you're talking about the types of data that they have been handling, right? So it's going to be moving from a plain vanilla, maybe a data center or a server farm or a hyperscaler. So that would move up the value chain in the network infrastructure, right? So just to give you a highlight, specifically if we're talking about the gargantuan efforts which are happening in automation, and we also see a lot of talk which is happening with the respect to the robotics and so on, right? So data center management is going to play a very, very important role. So coming from your perspective, Sudipta, and from your background, right, can you please throw light on how data centers are going to morph, if I can use that word, right, as they start moving at breakneck speed to the edge? Over to you, Sudipta.
Sure. I think the three things are playing a very, very significant role in the transformation of the data center and the hyperscaling the cloud. I would say the AIML, the IoT, and the combination of this, which you see in edge, especially for local decision making, right? Now, especially for the AI and ML, right? So if you see that it has significantly changed the way the data centers can be managed, and a lot of things we are doing even now, which will change the whole scenario very fast. I would broadly, classify into four areas. So one is data mining and management part. Second is the analytics advantage that you get, right? Then the cloud security part, which is of course done through a lot of automation, can be done through a lot of automation, and most importantly, how you reshape the whole cloud infrastructure. So let me first talk about the data mining and management. Now, if you see the data management and control in the hybrid cloud, especially, AI can help organization it very well in terms of effective management and control of data, right? Even deciding the source, how you use it, what is the timing and frequency, etc., etc. Everything can be determined. Then the seamless data access. Yeah, I mean, if you see that the AI uses data as its input for the input performance, and that can be performed through the seamless data access. Because there is a huge volume of data, you have to also understand. So basically, slicing, dicing, and basically giving away the garbage is also very, very important in that. The next one is the analytics part, right? So we are all in the insight-driven age, right? So, and especially if you look at so your basically you get data, ingest, insight, and action. These are the three steps for any decision making. And the cloud obviously stores the data. So basically, if you see that all the inherent elements which are embedded today through the AI, which can actually connect these three dots very well, right? As I said. And the other aspect is the cloud security and automation part. So automation, obviously, there are a lot of, as we know that we have so many repetitive tasks that can be automated through automation. But the most important part is cloud is something which is of course not control of a particular entity, because especially for a public cloud. Now a lot of those security aspects, right, that you can, the security monitoring and the remedial actions that you can do is you can do through automation, and that is a very, very important aspect which is changing the future of data centers. And the data analysis also you can automate it without any human intervention. This is the other aspect of the automation, right? And the last but not the least, the reshaping the cloud infrastructure. So if you see, there are a lot of pre-built combination of storage and compute resources can be used. When cloud started, our focus was more on the storage side. Today, cloud is no more storage, as you all know. It's a combination of a lot of computing powers, a lot of analytical powers. So that's very important. And this interconnect resources, helps in accelerating the automation of AI workloads also. So this whole the cloud infrastructure is transforming from what used to be once upon a time just a storage into something which is a very, very intelligent infrastructure which will help you to transform your business completely.
Yeah, thank you, Sudipta. In fact, you hit the nail on its head, so to speak, right? So, I mean, as data centers capability change, right, moving into proliferating into hyperscale enterprise location and smaller compact edge-based kind of computing and sites, right, their respective capabilities will also change, and software-defined data centers will also deliver a host of services, not just from physical hardware standpoint, but in a virtualized environment. So in the interest of time, I think we have one last question, which I would like to point it to Mr. Vikas, and the question would be more to highlight again from his perspective from Infineon on how. The question would be to see what's the scope for embedded artificial intelligence for different flavors of the cloud, and especially keeping hyperscalers and data centers in mind. Over to you, Vikas.
Okay. So, see, when you talk about embedded AI, right? So, with the term, it comes into our mind that, yeah, when we're talking about embedded AI, it covers maybe sensors, IoT, edge devices, right? But if you ask me originally, there is my perspective for looking into this kind of problem statement or this kind of area is that there is not only one solution for every problem statement. Yeah. So I divide myself into three categories, I would say. One is, assume you have a use cases of embedded AI where you want model to be, let's say model is getting trained in the cloud, like Pradeep also mentioned, right? That you can train the model in the cloud. And now I want to use the model only for inference. That's it. And this is like a one use case. And if you see, I have cloud, I have edge devices, or let's say I have a sensors, and you can take a use case, let's say smart lights. In this kind of scenario, you don't need a edge devices. Yeah. So you can directly club, you have a cloud, you have a data centers where your model is getting trained, you put your model on cloud, you do the inferences. So this is how you bridge the gap between the two worlds. Second area is that you have model is getting trained now in the cloud, but you are using it for inferences. But on the other side, you need a real time power or real time without any latency on the edge, let's say. Yeah. For example, autonomous vehicles where we are getting, not autonomous vehicles, let's say very easy example is speech recognition, what we are having now, right? So you can train your model on the cloud, but on the other side, what you can do now is for processing the data that is coming in the real time. If you do it cloud, then you expectation is the latency need to be very very less. But currently in the market, what people are trying to do is they are using the like hardware accelerator, maybe you know about it, and edge nodes on the devices itself to process the data, not for the modeling part but only for processing the real time data. That is how people are currently going in the direction of hybrid architecture. Yeah. And third perspective is, so you have like autonomous vehicles and all where you want model to be retrained it on the edge. And this is the challenge. If you ask me today, we have powerful devices on edge where we can train the model on the hardware, but do we see that as a future? I'm not sure. But on the other side, if I say that if we go into this direction of hyperscalers and all, where if we train the model in the real time itself without any latency and get back to the edge devices, then you actually bridge the gap between the two worlds. So that's what I feel, that's what we have to do, I think, in future. But yeah, no comments on what will happen. But yeah, that's my view.
Yeah, philosophically put, right? That's pretty well said because, like they say, the past is history, the future is mystery, right? But we need to
Yes.
plan in the present. So that's
Yes.
where we are with respect to embedded artificial intelligence. And this is not going to be just some another buzzword for the year, right? It is
Yeah.
for real. And for beginners, right, embedded AI is going to play a very, very important role, especially with edge taking shape in a big way. And with the application of machine learning and deep learning, specifically at the software level, right, both at the device and system level, it's going to play a very, very important role. And this would help build smart machines that would simulate human intelligence, and the implications for technological advancements across various sectors, and the possibilities are kind of immense. So, in the interest of time, I think we will have to kind of summarize now. Thank you all, gentlemen, for all your fantastic insights. We went slightly above time, 4 minutes above the 1 hour which we stipulated for the panel discussion. But I think, it was all worth it. And specifically talking about the overall perspective of cloud, which is going to kind of juxtapose with AI and ML all the way to the edge for hyperscalers and data centers, right? Your perspective was very, very valuable. So, in summary, right, our like I mentioned in the beginning, our whole world is connected, and the pace of communication innovation is accelerating as end users are demanding faster, more responsive, and reliable connections. That's what they would see, and for them, the end user, right, whether it is enterprise or maybe a generic user, right, for them these things at the back end would be agnostic, but they would like to ensure that everything is available at the instant. But there's a lot of work which happens at the background, so that we ensure that as technologists we provide them with the meanest and the greatest of technologies. And for us as business folks, right, there is business to be made for everyone. There's a lot of money on the platter. It all depends on how innovative people can get, and they can kind of ensure that that is capitalized. These technologies which we spoke today are for the long haul, so to speak, and there's also a lot of runway ahead of these path breaking technologies and applications. So it's been a joy and privilege, folks, to interact with you amongst eminent industry panelists. On behalf of Keysight Technologies and EFY, we would like to thank Mr. Pradeep, Mr. Sudipta, and Mr. Vikas for their participation in this insightful discussion. Thank you once again. And participants, we hope this session was helpful to you. I hope you got a chance to fill up the poll on the pop-up which you got, as well as on the hyperlink which you had, right, on the chat box, so that you can share your perspective, which will help you, which will help us to improve our conversations better, right? So if you have not yet done so, please share your feedbacks in the survey form, which you will be pointed to immediately after this panel discussion. And we hope you will get a chance to fill up those. Also, you would also get an email after the panel discussion. You can also reply to that email, where you will also have a hyperlink which will point to you to us to the survey form. So on behalf of Keysight Technologies, I would like to thank you all for participating in this panel discussion today. The recording of which will also be available to you and on demand, so that you can share it with your friends, colleagues, and so on, so that, or you would like to go through this panel discussion again. With that, we would like to sign off this virtual event. All of you have a nice day. Thank you and bye.